Assalamu alaikum, dear students, respected colleagues. I myself, Dr. Farooq Ahmad Sheikh, Assistant Professor in the Department of Mathematics from Government College, Women's Navakadal. So nowadays we are preparing the e-content material for second sem students, and the topic which I have to assign for e-content preparation, that is based on the title differential equation. Now question arises: what is meant by the term order of a differential equation? The order of a differential equation means simple words में क्या the highest derivative involved in a given differential equation. जो भी given differential equation में highest derivative आकर करेगा that gives the order. If we see first dy by dx equal to 3 times xy, इसमें जो highest derivative that is a first order dy by dx, so we can say it is a first order. Yeah, if we say example third d2y by dx square minus 8 times dy by dx equal to 5x, it is again a differential equation. इसमें highest जो derivative that is of order 2. That is why we can say it's a differential equation of order 2. Okay, now next term is what is meant by degree of a differential equation. The degree of differential equation has a close connection with the order of a differential equation, which you have find in the previous slide. Now what is meant by degree? Degree is actually the power of order, but the differential coefficient must be in polynomial. See here example, it is actually d3y by dx 3, d3y by dx 3 whole is for 3 plus 2 times dy by dx का whole square minus x equal to 0. So it is a differential equation इसका order 2 3 है और जो इसका power भी है that is 3. That is why we can say it is of degree 3. If you see here example, question number first की जो पहला part है d4y by dx raised power 4 plus sin of d3y by dx 3 equal to 0. It is of order 4, but its degree is not defined because here the differential coefficient d3y by dx 3 is not in the polynomial. Okay, have you got? Now the next term which we have to explain, that is what is meant by an exact differential equation. A differential equation of the form m dx plus n dy equal to 0, where m and n are the functions of x and y, is said to be exact if it is exactly differentiable with respect to x and y. That means m dx plus n dy equal to some du, where u is function of x comma y. What is du? By definition of total differentiation, it is given del u by del x dx plus del u by del y dy. Here is the theorem first. The necessary and sufficient condition for a given differential equation of the form m dx plus n dy to be exact. M dx plus n dy to be exact. When we can say the given differential equation is exact, the necessary condition for this is that del m by del y must be equal to del n by del x. Here is the proof. See, necessary part में people will suppose m dx plus n dy be equal to exact. Then by the definition of exact, m dx plus n dy equal to some du. Then by total differentiation, du is equal to del u by del x dx plus del u by del y dy. Now compare the like terms on both sides. We get m is equal to del u by del x and n is equal to del u by del y. If we partially differentiate m with respect to y, we get del m by del y is equal to del square u by del x del y, and del n by del x is equal to del square u by del x del y. Now on the both sides of the RHS of the both sides, we get comparing that, we get del m by del y is equal to del n by del y. This is the given necessary condition. Now converse part में हम लोग suppose करेंगे this condition satisfies, that is del m by del y equal to del n by del x. Let us suppose integral m dx keeping y equal to u. Now partially different with respect to x, we get m is equal to del u by del x. Now if we see here, note down this value of m is equal to del u by del x. Now if we partially differentiate m with respect to y, we get del m by del y is equal to del square u by del x del y. But del m by del y by given condition equal to del n by, so similarly del n का value मिलेगा del square u by del x del y. Now if we integrate, we get n is equal to del square del u by del x. तो अब m का और n का वैल्यू जब सब्स्टिट्यूट करेंगे, we get m dx is equal to plus n dy is equal to du. That means it is exact. Okay. Here this is the working rule to find the complete solution of a given difference if it is exact. Now if a differential m dx plus n dy equal to 0 satisfies the condition del m by del y is equal to del n by del x. तो बेटा अब exact है and its complete solution is given by y is equal to integration of m dx keeping y constant plus integration of n dy, n terms are free from x, and it is the complete solution. How we can find it? Here we have the Bernoulli differential, or simply we can say it's the differential which is reducible to linear. First of all, you are aware about the differential equation dy by dx plus py equal to q, where p and q are functions of x are called linear, and we can solve this by making use of integrating factor. Here we have a differential equation dy by dx plus py is equal to q y raised for n greater than 1. This is called a Bernoulli differential. It is reducible to linear. How we can reduce down it? We will divide by the factor y raised for n on LHS. Then we suppose y raised for minus n plus 1 equal to t. Then we get a differential in dt by dx plus some constant pt is equal to, which is linear, and by procedure of linear which we have read from 12th classes, we make use of integrating factor and solve. Okay, now the integrating factor. Why we are using this term integrating factor? What is meant by the term integrating factor? Here is the slide for this. Sometimes differential equations which are not exact can be made exact by making use of some suitable functions of x and y, and multiplying by these we get exact. Thus integrating factor is of a differential is a factor such that if the equation is multiplied by it, the resulting equation is exact. Now the working rule, how we can find this integrating factor. Here are some rules given. Rule number first, if m dx plus n dy equal to 0 is homogeneous function of x and y, that m and n are the functions of x and y, they are homogeneous, then in such a case 1 divided by mx plus ny is an integrating factor, provided mx plus ny not equal to 0. Moreover, rule number second, if m dx plus n dy equal to 0 is of the form like this: function of x comma y, y into dx plus function of x comma y, x into dy equal, then 1 divided by mx plus ny is an integrating factor in this case, provided the condition mx minus ny not equal to 0, identical equal to 0. In the similar manner, rule number third, if 1 upon n del m by del y minus del n by del x is function of x only, in such a case it is for p f of dx is the integrating factor of a differential equation. Moreover, if 1 upon m del n by del x minus del m by del y is a function of fy only, in such a case we use areas for integral fy dy, integrating factor of a given differential equation. Hope all of you enjoyed the lecture. Thank you for your keen concentration. Thank you a lot. Assalamu alaikum wa rahmatullah.